Okay. Hi, everybody. The previous lecture was about logistic regression. It was an introduction about logistic regression. We have defined the most important types of logistic regression and how the logistic regression task begins with finding the linear model as a result of learning the dataset. And after that, we have analyzed the convergence which took place within the algorithm so that at the end we achieve probability values within the range of 0, 1. And in order to get at the output categorical values, we used a conditional inequality with a threshold equal to 0.5, for example, so that the output will be 1 or 0, yes or no, day or night, and so on. Today's lecture is devoted to logistic regression data sets. The data set which is used in logistic regression is always having a target with labels which are categorical values. These values cannot be processed by the algorithm and must be converted to numeric values. This is a specific type of data sets. Anyhow, data sets exist in different repositories, but as an example for that, I can say the Kaggle repository or GitHub repository or UCI and so on. Also, data sets exist within the programming libraries. They exist within the scikit-learn or SKLEARN, and they also exist within the Statsmodels and within the R language datasets and so on. So at first we have to download the dataset, then carry out specific pre-processing tasks so that the dataset is adequate to be used by the model. We shall take as an example the iris dataset. This dataset exists in different repositories and it is multinomial, so it is standard dataset and could be used as a successful example. We shall illustrate for you how we can download this dataset from Statsmodels and how we can do that with SKLEARN also, and how we can do that by using the URL of the iris dataset if it exists in a specific repository. So let us begin with this example. Here we shall import pandas as PD and statsmodels.api as SM. SM here is an alias for statsmodels, and the API is one of two interfaces which exist within statsmodels. So we can use statsmodels.api or statsmodels.formula.api. Instead of as SM, there it will be as SMF from the word formula. So we have two specific interfaces for statsmodels. Really, when working with statsmodels.formula.api as SMF, there is some advantages, and one of them is that we can convert categorical features to numeric ones directly without using any conversion tool. But regarding the target categorical values, they must be converted by using specific instructions. Okay, so now we have imported the stats models, and now we want to download the iris dataset by using stats models. Stats models include a method called get rdataset. Get underscore rdataset. This method, which is within the stats models, can read the data sets which exist in the R language, in the R library. The difference here is that the R library really includes a large number of data sets. The number of data sets which exist in stats model is very limited in comparison with the number of data sets which exist in the R library. The R library includes about 1,000 data sets, which gives you really mobility and chance to select any data set required in any field required. So, as an example here, we called the get rdataset function and passed there the name of the data set of interest. Here it is iris. As a result of that, we shall get a target called or given a name iris. This iris here is not a data frame, neither it is a Numpy array. It is a container wrapper which includes, in addition to the data, titles, packages, and other relative information to the data set. So we cannot use it directly. We have to extract from it the required data and the necessary target values. But if we do that, and now we will see how it is done, the value which we will get will not be a Numpy array, it will be directly a data frame. So iris dot data, here we are calling from iris the data, and we shall get here a data frame structure. Yes. I also call data again, iris.data, and assigned it to a variable called iris1, for example. Iris1 here also will be a data frame. Suppose I don't know exactly what the iris data gives. Does it give a data frame, or it gives a Numpy array, or what is in general the type of data there? Here we can use the instance function of Python. So if we print instance between two brackets and pass there the name of the data structure, iris1 here it is iris1 a PD data frame? Is it a data frame? This is the question. The result will be yes or no, true or false. When we run this, we shall get the answer is true. If I go downwards, I shall find it is true here, which means that the extracted data from the iris is already given as a data frame. But if I do the same for the total, the original wrapped values within a container called iris, and apply this to the iris only, and ask, is instance iris a data frame? The answer will be false. It is not a data frame, because there is a lot of other items in addition to the data frame. But the good thing here is to know is the data which is called from the wrapper iris is already a data frame and could be used directly for analysis. Anyhow, also you can ask to the program, of course, to give you some information about the data set by using the function .info. Here we have got iris1 as a data frame. If you want to know about this structure, what does it include, what is the names which are there, what is the number of instances or samples there, here will be given within this short information about the data frame. So it is advisable to check with it, because it is short, but gives valuable information about the data set. If we look what we have here, so this is the data which we take from the info function. It tells us that we have 5 columns. The names of each of the columns, it gives us an information about the total of each of them, 150 samples, 150 samples. It gives also very useful information that there is no feature here of these 5 features which contains a null value, which means that the data set is ready for use and doesn't need to carry out any additional corrections. None value here is 0, none value here is 0, and so on. Yes. Anyhow, the values begin with 0 and end with 149 samples, and the total will be, as you see, 150 entries or samples or rows, and the number of columns is 5, as shown here. From 0 to 4 there are 5. So as you see, this is also useful to check with. After that, I have printed the head of the, as I know now it is a data frame, so I can use the head function here. When these 2 brackets are empty, it will give me the first 5 rows. If I want different number, I can write the required number between brackets here. And also, I have asked the program to give me the shape of this data frame. So, as you see here, we can see that the head 5 values 1, 0, 1, 2, 3, up to 4. These are the 5 values. These are the names of the columns. This is the target called species. And here is the category values representing the labels. And the shape here is given 150 by 5. This is the same information as we have got through the info function. Okay, now we have the data frame, and we need to carry out some, or we may face necessity to carry out some of the following conversions or actions. Suppose we will need to rename the target. The target is given a name species, and we need to change it to another name called class, for example. This is just for consistency because there are the classes. So to do that, we have to use the rename function. Rename within 2 brackets, as you see here, and we use a dictionary. Here is a dictionary which includes the original name and the target name which we want to have. The new name which we want to have is a class. This is the original name, species. This is within the dictionary. And now this dictionary is assigned to the columns, of course. And now iris1, this is the data frame dot rename. This is the function which we have. it will rename all the items in this column and assign it to the data set, which is called iris new. So iris new now will have a target called class. If we print the iris new now, we shall have the target. It was here species, and these are the labels. Now it will be class with the same labels, but we have changed the name of the target. But we still have categorical values of the target. So we need to convert these categorical values to numeric ones. This is a specific requirement when working with logistic regression. For this, we shall use two methods to do that. One of them by using or creating a dictionary, which includes the case which represent the original values. Cetota now is going to be 0, to be mapped to 0. Versicolor will be mapped to 1. Virginica will be mapped to 2. These are the three labels, categorical labels which we have, and we want them to be 0, 1, 2. This dictionary is assigned to a variable called label map. Now this label map will be passed to a function called map. Now we select, here is our data set, iris new. It is called iris new. We select the column which is called class or named class and apply the mapping function or mapping dictionary to all elements of this class. And this result now will be assigned to a column in the same iris new, but it is called target. So now we shall have two columns. One is called target, which we have created, and the previous one, which is still called a class. But the target will be having numeric values. If we go downwards and consider what we have, so the iris head after conversion, we shall have the previous target as it was before, and the newly created target with numeric values. Of course, they are not all zeros. If you go downwards up to 100, you will get ones and twos, also values. Now we have this data frame, but this data frame includes an additional target, so we have to cancel it by using the drop function. We shall use a drop function to finish with this column. So iris new drop, this is the function of drop. What we will drop? We will drop the column which exists in columns and named class. So this class now will be dropped, and we will get again, I call it again iris new, and this last one, iris new, will have only the target column with the numeric values. If you go downwards, we shall have this target column with the numeric values. Suppose you wanted to keep the name class instead of target, you have no problem with that. Here you can write instead of target, if we here write class, for example, and run the program, yes, we shall have, now the program is running, still running. Yes, it has finished. If we go and look what we have, we shall have that. Here it is a class. It is called a class with the numeric values instead of the target. Now we go back. I think we have done everything here. Before leaving this page and going further, here is the SKLEARN dataset. I have shown you, I am showing you this dataset. It includes about 20 datasets, which could be also downloaded and used. And one of these datasets is the iris. It is called here, the name is load iris, between two primes here. Of course, there are other famous datasets. For example, load diabetes, it is really well known. Load digits, it's also well known and very often used. Load wine, make plubs, yes, and so on. Okay, now we shall move forward. And maybe I have forgotten to tell you something here. Yes, really, I have forgotten to tell you about conversion. Instead of making this dictionary and working with the map, there is another way to do that and more simple, as it is shown here. The data set which we have is iris new. It was called iris new. Iris new here, we select a class. This is the column which we wanted to convert its elements from categorical values to numeric values as type between two brackets category dot category codes. We do not add anything except, as you see, we give the name of the data frame and the name of the column which under consideration. And now we shall get a new data set with the elements of the class categorized. Let us try to show you. Now I shall take away this hash. And now I shall, it should be a little bit shifted to the left. Now it is correct. And I have to hash this here. I don't need it to be included in the program now. And I have to take this away. Now, if I run the program and have a look at iris new, because I have printed it now newly, iris head, I want to print the iris head after conversion. It is iris new here, iris new head. So if I run the program now and look at iris new head, now let us see the iris new iris new. This is the head, as you see. No, this is not now converted. Now it is converted. This is the iris head after conversion values. The iris head after conversion, it is the same as it is shown here. So you can use either this instruction or you can use this approach. Maybe this is clearer for you. You do not need to remember it hardly as you do with this one. And maybe by time and through repetition, you could be accustomed to this instruction. It depends what do you want and on your flavor. Okay, now let us try to illustrate for you also another example. When we download the iris dataset from SKLEARN, you have seen it there. It is there, and it is called load iris. So here from SKLEARN dot datasets, I access the datasets and import from there load iris. Now load iris could be used by the program. Now if I use this function load iris and call it, these two brackets means you are calling it, and assign it to an object called iris. This iris also is not a data frame, neither it is a Numpy array. It is also a wrapper made by SKLEARN. Usually it is called a bunch, B-U-N-C-H, a bunch object. Again, if you ask, is instance iris a data frame? The answer will be false. The answer will be false. Yes. Why? Because there are other values in addition to the dataset itself. Now, if you ask the program to print this iris to be sure what is there, you will get this picture, a lot of information. This is, for example, a Numpy array, which is showing the values of the columns which represent the features. This is the first feature, the second, the third, and the fourth feature, which are there. There is no columns here. There is no targets here. This will be 150 lines, because you remember the shape 150 by 5. Here you shall see another data which is about the target and the values of the target beginning from zeros to ones and twos. Moreover, you will have more information about, for example, the target names, Setosa, Versicolor, and Virginica. You will have also the number of instances and more and more. Why? This is why you cannot get, this is not considered as a data frame or as a Numpy array. This is an envelope, a container which contains all these different kinds of data. So we are still here, as you see. We have printed it and we didn't find that this is a data frame, or is it a Numpy array? Here I am trying to convert it to data frame. Why I am doing that? Really, if I extract the data from iris and take iris and unprinted iris.data, I shall have a data, and this data will be a Numpy array. It will not be a data frame. Remember, in Statsmodels, we directly get data frame. Here we directly get only Numpy arrays. Numpy arrays means you have data only without any names for the columns and the target. Neither you have indexing for the rows. So as you see, SKLEARN can work well directly with Numpy arrays, as it is the case with LabVIEW. In LabVIEW also, you remember, when we looked at some examples, it doesn't require the names of the columns and the names of the indexes, and we can directly work with the data which represents the features and the data which represents the target. And you may remember when I have saved the data which I have got in Python and read it as CSV file in LabVIEW, I have deleted the names of the first row which exist in the first row and deleted all the indexes which existed in the first column, so that to have pure data, because LabVIEW requires only data without names and without indexes. Okay, now, as I told you, I have converted to data frame because I know now that the data there is a NumPy array, and I need to convert it to data frame. Why is this compulsory and I should do that? No. If I want to carry out the logistic regression task with SKLEARN, I do not need to convert it to data frame, but it is preferable. It is recommended. It is easier to manipulate the data with data frames than to do that with NumPy. Remember that NumPy or Pandas library was developed on the basis of NumPy and Python. Okay, so what I need the data, and I need the names of the columns. So I call the data frame function from Pandas and pass there the data, which is iris.data. I have accessed the data within iris now. Dot here means I am accessing the data, which is the values of the features only, which exist in the iris, and assign it to a variable called data. And also I have accessed the feature names you have seen there now, which exist in iris, and assign it to the columns, which means that columns here mean the feature names. So now I have the feature names and I have the data. I can develop a data frame. The output will be a data frame. This data frame head now is printed. You can see it. This is the data frame head, DF head. So now we have the names of the data, which is only the features. As you see, the values, which represent values, and the indexing, but there is no target. There is no target yet. This is a data frame of the features only. So in order to have a series, not a data frame for the target, also we have to do that separately. Okay. So what we have done just now, we have created a data frame for the features, and also now we shall create a series for the target. So iris, I access the target which exists in the iris. The target here means the name of the values which is there, the value, sorry, target here is the values which is there, and assign it these values which are existing in iris. I assign it to a column, new column called target in the data frame, as if I am creating a column in the data frame called target and passing the values there. And now, if I print this df, I print the first 5 rows and call it df2. So this will be the target new name, df2. If you go data frame 2, let us see data frame. Hey, here it is, data frame 2. Here is the features which we have before and the added target. We have added a target there. Now, for logistic regression task, we know the values and the names of the column which represents the target and the names and columns which represent the features. Suppose we need to change the indexes in the data frame. Normally, or let me say, as a default, the indexes are numeric in the data frame. But suppose you have an indexes which are not numeric, and you need to have them numeric. So we use a function called reset index, which means reset the index to the default value. So for this specific data frame which we have, which we suppose that it has a categorical indexing, we apply reset index. Now the indexes will be changed to numeric. If we did not try to drop true, so we will have two columns, the new column with indexes which are numeric and the old column which was categorical. So normally we add drop equal true, which means we will drop the original categorical column of indexes, and now we will have only the numeric one. So if we go now and print df reset, this is the name now given. After that, I have printed the first 9 rows. You will have df reset, you will have indexes from 0 to 7. There is no categorical values. This is okay, even if we suppose, and now in my case here, the original indexes were numeric, and now they're still numeric. There is no problem. There is no problem. So there is no fault here. Yes. Now we know some new information regarding the resetting of the indexes in the data frame. Suppose you have a data frame and you want to convert it to a Numpy array. Why? First of all, because you have no problem with this because SKLEARN works well with the Numpy array. And secondly, maybe you need to work with another language like LabVIEW. To do that, you use dot to NumPy converter. So the data frame which we have df reset now, which is already existing, dot to NumPy function. Now it will change this df reset to a NumPy array. It is called final data. But this final data now will not have any name of the features, neither the name of the targets, and we can have only the data because NumPy array does not have these names. So if we go and see what we have printed here, final data from 0 to 8, final data, here it is, from 0 to 8, you will find only the values. There is no names for the features, no indexing. You have to remember these things. I am telling you these things so that you may not forget it in the future and keep eye on it. Okay. But what we have done here also, we can do it in another way. Suppose you have the data frame which is called df, and you need to convert it to a NumPy array. What you need to do is only use dot values. If you, instead of dot to NumPy, use dot values, you will get the same result. I have named it df2 and printed it as df2 with 5 rows. If I go to df2 and see what we have got there, df2. Here it is, df2. Here they are, the first 4 arrays, only values, without names and without indexes, the same as the above one. So you can use either of them and be accustomed to any of them as you wish. One interesting application here is required very often here, which is to divide the dataset. If you have a complete dataset and you need to divide it to 2 groups, one of them representing the features X array or Y series, X or Y. So here, if you have already converted the data to a NumPy array, you can directly use this notation by using slicing of the arrays. This is the array which we have, the final array. It was called final array here, final data. Now, this final data, we need to have all the rows. This colon means all the rows. And we need to have all the columns up to the last column. The last column is not included. So with this, we can get all the NumPy array values for the features. If you want the columns, the target, we have only one target, one column. So we need to have all the rows, as you see this column, and the last column only. At the end, we get only the values representing Y. Remember that this works only when you have the last column representing the target. If the target is not existing at the end, so you need at first to move this column to become the final one, if you want to apply this approach. Okay. Now, here really are additional things I have done so that I can save the X and save the Y as CSV files to make use of them in the future in other examples. So I will not take care of it, but I want to show you another important things to work with. Again, we want to divide the data set to an arrays representing the features or data frame representing the features and a data frame representing or not a data frame, a series which represents the target. So this is also could be done here. Suppose we have this data frame df. Now I want to take away the last column or any column which I select its name, which is considered for me the target. So df drop columns equal target. So I select the column with a name called target and drop it from the data frame. And the rest will be called X. This is the data frame which represents the features. If I want to keep only Y, so I can work like this. I have the data frame. I use the drop function. What shall I drop? I shall drop all the columns which are existing except the last one. So here columns equal df columns, all the columns I have to drop except the last one, which will be used as the target. I called it y1, for example. Now, if you look at y1, you will have only one column, which represents the target, which is extracted y1, where it is. Here it is, y1. Here is the column, which, of course, these dots here represent that there is a number of intermediate values which are not shown here. This is the series which represents the target as containing indexes and containing a name and values. If you want to have only the values, you are working, for example, with a Numpy array, so you will get only the values here as they are given here, and the array will be two-dimensional array configuration. Well, I think that this is very important to take care with, very important to go through it slowly and to comprehend how you can do with it, because I have selected for you the most common, the steps or conversions which you may face when working with logistic regression. The last thing I wanted to show you today also is usually we can also go to the internet at any of the repositories which are there, and there we can find the URL of the required dataset. For example, for iris, there is a file called iris CSV. This is the URL of this function existing at this location or repository using the URL, and because it is usually and most of the time the datasets are saved there as CSV files, you can use the read CSV of the pandas and pass there the URL of interest, and you will get directly the dataset. And because this is you are reading as CSV file from PID using PD, so consequently the data will be a data frame. So if you ask, is instance iris PD data frame, it will give you yes, true. This is a true data frame. The other steps which are given here are some repetitions to what I have done before, just to show you that we can get the same even we are downloading the data from a different repository. Well, now with this, I think now you know what do we mean by logistic regression. Well, you know how to work with the data, to download the data, to divide the data to X and Y groups, to convert the data from data frames to Numpy arrays, or to change the names of the columns, to move the columns and to the required position, to change the indexing to the default value, and other interesting things. Okay, with this I finish this lecture. I hope that in the coming lecture I shall begin working and applying logistic regression algorithms by using stats models and also by using the SKLEARN. And of course, later on, we shall also work with the LabVIEW Play and with the LabVIEW Analytics and Machine Learning Toolkit. Wishing you a happy day and goodbye.